We're focusing on a core concept for the EPA 608 Type 3 exam, which is how low-pressure centrifugal chillers behave when they leak. This is one of the most confusing topics for technicians because it works opposite to every high-pressure system you've ever worked on. The key to passing is understanding that low-pressure systems, like those using R123, operate in a vacuum, meaning the pressure inside the evaporator and low side is below atmospheric pressure. Because of this pressure difference, a leak doesn't cause refrigerant to blow outward. Instead, it sucks atmospheric air and moisture into the system. This is a guaranteed exam question. An exam scenario might describe a system with a leak and ask what is being released. The trap answer is refrigerant. The correct answer is that nothing is being released. But non-condensables are being drawn in. These non-condensables, primarily air and water vapor, cannot be condensed back into a liquid with the refrigerant. They travel through the system and accumulate at the highest point of the condenser, where they get trapped. This buildup of air raises the head pressure, or condenser pressure, which is the #1 symptom of a leak in a low-pressure chiller. This increased pressure forces the compressor to work harder, reduces the chiller's efficiency, and can lead to corrosion from moisture-forming acids with the refrigerant and oil. To deal with this constant infiltration of air, every low-pressure chiller is equipped with a purge unit. The purge unit's sole job is to remove or purge these non-condensables from the condenser to maintain system efficiency. An exam question will often test this by asking what excessive purge unit operation indicates. The answer is always a system leak. Now, how do you find a leak that sucks inward? You can't use soap bubbles while it's running. The standard procedure is to perform a standing pressure test. First, you recover the refrigerant. Then, you charge the system with dry nitrogen to a pressure slightly above atmospheric, but not exceeding 10 psig, to avoid tripping the rupture disc, which is a safety device set at 15 psig. After pressurizing, you can use an electronic leak detector to find the source of the nitrogen escaping. Another method involves circulating warm water through the chiller tubes to raise the refrigerant pressure naturally above atmospheric, which can then be checked for leaks. Here is a simple phrase to remember for the exam. Low pressure sucks, high pressure blows. This mental shortcut will help you instantly recall that a leak in a low-pressure chiller sucks air in, while a leak in a high-pressure system blows refrigerant out. It's the most critical distinction to master for the Type 3 exam. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.